Hello and welcome to the very last section of the entire quarter. This is section 14.3 on linear systems and three variables. All right, so let's go ahead and just jump right in with problem one. It's saying solve each system using elimination. All right, so you can see we have the three equations with the three unknowns, A, B, and C, and our job, of course, is to find the values of A, B, and C that will make all three equations true. And so as a little warm up here, let's look at this system. We have 2x plus 3y is equal to 5 and minus 2x plus 4y is equal to 16. And the thing that stands out here is that these x terms, the 2x and the negative 2x, are equal but opposite. So if I add these two equations, well, on the left side, I can see that the x terms are just going to drop out. 2x plus a negative 2x is a 0x. For the y's, I have 3y and 4y, that's 7y. And then on the right side, 5 plus 16 is 21. So then dividing by 7, I immediately arrive at the value for y, and I see that y is 3. All right, now to find x, now that I know that y is 3, I can substitute 3 in for y in either equation 1 or 2. So I'll go ahead and just use equation 1. So this is 2x plus 3 times y, and y is 3. And that is equal to 5. So now I can go ahead and solve for x. I have 2x plus 9 is equal to 5. Subtract 9 from both sides, and I get that 2x is negative 4. Divide both sides by 2, and I see that x is negative 2. Okay. And just as we were doing in the last section, we'll go ahead and write our final solution here as an ordered pair, right? So x is negative 2 and y is 3. And so this is the solution to the system, right? Now, each one of these equations is linear, so the graph of each equation is a line, and this point we just found, negative 2 comma 3, is the point where these two lines intersect. All right, cool. So what if we had, say, something like this? 2x plus 3y is 5, and x minus 2y is equal to negative 8. Well, notice here the x terms are not equal but opposite, and likewise for the y terms. So the idea here is to fix this up so it resembles something like this first example, and then I can go ahead and add the equations and eliminate one of the variables. Okay, so let's see here. Now, if I have a 2x here, see if I were to multiply this x by negative 2, then I'd be in good shape because I'd have 2x and a negative 2x. But I have an equation here, so I have to multiply both sides of the equation by negative 2. And on the left, right, I have to multiply this entire expression, x minus 2y, by negative 2. So I'm going to write this multiply by negative 2 here just to denote that the entire left side is going to get multiplied by negative 2, and the right side here is going to get multiplied by negative 2. And we're just going to leave this top equation alone because it has a 2x for the x term. And again, our objective here is to fix the system up so the resulting system will look like this, so we can uh, uh, eliminate, in this case, the x variable. So this is going to give me what? Well, x times negative 2, that's negative 2x. And then negative 2y times negative 2, that's positive 4y. And then on the right side, negative 8 times negative 2 is a positive 16. And now I can go ahead and add. And just as in the first example, these two x's drop out. I get 7y, and 5 and 16 is 21. In fact, this resulting system is exactly the same system as our first example. So the rest of the details are all the same, and we arrive at that same solution of negative 2 comma 3. All right, so now what we're going to do is apply the same kind of method, right? This is what's known as the elimination method to a system of three equations with three unknowns, okay? So like we did in each one of these problems, right? We choose a variable to eliminate. In this case, we eliminated x. And to eliminate the variable, right, if it's already set up for us, like this problem, where the variable we're looking to eliminate has for its term, say something like 2x and then its opposite here, then I can just add and then I'll have eliminated the variable. If it's not the case, well then I might have to fix it up, right? By maybe multiplying one of the equations by a certain uh, non-zero value. Okay, so now let's go ahead and look at part A of question 1. So looking at the A's, well, there's none of these terms, right, are equal but opposite, and likewise for the B's and the C's. Okay, so what I'm going to do, I'm going to go ahead and just choose two of the equations. I'm going to work with equation 1 and equation 3, and I can eliminate A if I multiply equation 3 by -2, just like we did in the last example. Okay, so let's go ahead and start out with that. So we'll label these equations 1, 2, and 3. So I'm going to use equation 1 and equation 3, and I'm going to choose to eliminate the variable a. So we're going to do that by multiplying equation 3 by -2. I'm going to leave equation 1 alone. So I have 2a plus 3b minus c is equal to 1. And then I have minus 2a plus 4b minus 6c is equal to -22. And then go ahead and add. And I see the a terms drop out, and then I'm left with 7b minus 7c is equal to -21. Okay, now note here that every one of these coefficients is divisible by 7, so I'm going to go ahead and divide both sides by 7 as a simplifying step. So this gives us b minus c is equal to -3. And unlike this last example where we had just two equations with two unknowns, right, I got that y was 3 immediately. So here, with 3 unknowns, right, I wind up with an equation that involves both b and c. So I can't find the numerical values of b and c quite yet because I still have 2 unknowns in just this one equation. But I'm going to go ahead for the moment. I'm going to label this equation 4. And now the strategy is, okay, let's play the same game where we eliminated the variable a, and that we arrived at an equation involving just b and c. Let's do that again. Let's select 2 other equations. So here we did 1 and 3. Now I could use 1 and 2 or 2 and 3. And if I'm going to eliminate the variable a again, I think 2 and 3 are going to be the easier choice because I can just multiply equation 3 by -3 in that case, and then add, and that'll eliminate the variable a. So let's do that down here. So here's equation 2, here's equation 3, and so I'm going to go ahead and multiply equation 3 by -3, and we're going to leave equation 2 alone, and this will give us 3a minus b plus 2c is equal to 14. And then for equation 3, that'll give us minus 3a plus 6b minus 9c is equal to a -33. All right, so now let's go ahead and add. So we're going to eliminate a here. And then for the b's, I have 5b. And then for the c's, 2c minus 9c is a minus 7c, and then 14 plus a -33, that's a -19. Okay, so now what I'm going to do is call this equation equation 5. And see, it also only involves the variables b and c. And so now what we can do is put equations 4 and 5 together in a system. So let's go ahead and copy those over and see, since they only involve b and c, we can go ahead and solve this system also using elimination. And once we know the values of b and c, right, we can go ahead and substitute them in to either, or really any one of these equations, 1, 2, or 3, and that's going to give us the value of a. All right, so to solve this system here, let's go ahead and eliminate say b. Okay, so I'm going to multiply equation 4 by negative 5. I'm going to leave equation 5 alone. So this will give us minus 5b and then plus 5c, and then on the right I have 15. And then we're leaving equation 5 alone, so 5b minus 7c is equal to a negative 19. And then add, and this gives us what? Well, the b terms drop out. I have minus 2c here, and this is a negative 4, and so I get that c is equal to 2 if I divide both sides by negative 2. All right, that's nice. And now if I want to know what b is, let's go ahead and use equation 4. It's a little bit simpler. So I have b minus c, which is 2, and that's equal to negative 3. And so if you add 2 to both sides, we get that b is negative 1. All right, and so now for just the very, very last step, we need the value of a. And since I know that b is negative 1 and c is 2, we can just take our pick here from equations 1, 2, or 3. And I'll go ahead and just use equation 1. And we get that 2a plus 3 times b minus c is equal to 1. So go ahead and punch in the value of b here. That's negative 1. And then I'm going to punch in the value of c. This is 2. And now we can solve for a. So we get 2a minus 3 minus 2 is 1. So this is 2a minus 5 is 1. So add 5 to both sides. You get that 2a is 6. Divide both sides by 2. You get that a is 3. Okay, great. So there are the values of a, b, and c. So our final answer here, we will write as a ordered triple now. And we just follow alphabetical order here. So A, B, C. So A here is 3. B is negative 1. And C is 2. Okay. So there we have it. Now, of course, we could check our answer by just substituting these values back into each one of these equations. And I'll leave that to you. Now for another problem to practice here, I'm going to leave this one to you. This is part B. Now I'll go ahead and put the answer up here just as a check for you. So it turns out that x, y, and z are equal to 2, 1, negative 2. So in other words, x is 2, y is 1, and z is negative 2. So I encourage you to solve this system in much the same way here using this elimination method and then check your work. All right, well, that's going to do it for this video. Thanks so much.